Hybridization is considered a mathematical model because it mixes atomic orbitals using math to create new orbitals that match the shapes and bond angles chemists observe in molecules. Think of atoms like tiny houses with rooms called orbitals where electrons live. And sometimes the rooms need to be rearranged so the house fits together better when it connects to other houses. Hybridization is the math way of remodeling those rooms by adding and subtracting wave functions, so the new rooms point in the right directions for bonding. The model does not say electrons physically jump into different rooms, like moving furniture. It says the best description of the electron's behavior comes from combining simple orbital shapes into new shapes that predict bond angles, and bond shapes we measure in experiments. Chemists use the rules of quantum mechanics to form these combinations, but the actual math is a tool to create orbitals with the right geometry and energy, not a literal picture of tiny spinning balls being glued together. This is why hybridization works well for many molecules, but is still described as an approximation or a model. A common mistake is thinking hybridization proves how electrons actually move, when it only provides a useful description. Reminding students that models simplify reality helps avoid this confusion. Another error is applying a single hybridization rule rigidly to complex molecules, so it helps to check experimental data like bond angles or use more advanced calculations when things do not match. Students sometimes try to assign hybridization to atoms in delocalized systems as if electrons are fixed, and the quick tip is to treat delocalized electrons with resonance or molecular orbital ideas rather than a single hybridization picture. For more videos and resources on this topic, check out www.gumballdegree.com.